Welcome to Programming in Modern C++. We are in week 3 and we will be discussing module 14. In the last module, we have taken a look into the constructor and destructor, the basic process of creating an object and releasing it with taking care of all dynamic data and so on to have a very well defined life cycle. And we have shown examples of that, the life cycle, lifetime of variables that are objects that are automatic, that are static and that are dynamic. In this module, we will take a couple of more examples of object lifetime which you should practice, and we will primarily deal with the issue of copy. How do you make copies of objects and what does that mean in C++ and why is it important? As you will see in several slides in this presentation, the title is prefixed with practice in blue, and those slides are not what I will discuss in the presentation, but those are included so that you can study them in depth and possibly try them out to have a better understanding of the respective issues. Here is the module outline as every time. So, in terms of object lifetime, we want to answer a very specific question in this slide as to what is the order in which the different data members of a class is constructed when the object of that class is constructed. So, you have an object and you have different data members. So, to construct the object, you need to construct each and every data member. Those may also be user defined types. So, they will have data members. So, the process goes recursively in that manner. But with a simple example, we try to illustrate what is the order in which they are constructed. Is it by the order in which you write them in the initializer list, or is it by the order in which you list them in the class definition? So, to start with, we have a simple class containing 2 integer data members, and to be able to understand as to which one is actually getting constructed, we have created 2 insertable dummy functions. So, instead of directly copying the value, we will pass the value that we want to initialize into this int data member to the init function, corresponding init function, so that I can print the message and know in which order they are happening. So, this is these are the 2 data members, and I have in the initialization list I put the initialization of M1 first, and I initialize it with the value returned by this function. This is just an instrument to tell us that we get to see in which order they are happening, because the print messages will happen in that way. So, I do that, and when I see that init M1 has happened first and init M2 is happening second. Now, the question is it because is init initialization of M1, construction of M1 is happening first, is it because M1 is earlier than M2 in the list of data members in the class, or is it because in the initialization list it has been initialized first? So, to test that, let us change the order of data member list in the class. I now list M2 first and M1 next, and I do not change their order in the initialization list. Now, as I do this, I find that in the invocations are in the same way using the functions. Now, I find that init M2 is happening first. So, this clearly tells us the init of M2 is actually listed later in the initializer, but it is happening first because it is the first data member, it occurs before M1, So, this simple program tells us that the data members will always be constructed in the order in which they are listed in the class and not in the order in which they are given in the initializer list, which could be anything, right. And this is very important to understand, because a particular class may have multiple different constructors, as we have seen. So, they may list the data members, they may need to put the data members in any order whatsoever they want to. So, if that were directing the initialization order, then there would be ambiguity. So, when it is in terms of the order in which they are listed in the class, obviously there is no ambiguity, because there is only one list, irrespective of how many constructors you may have for the class. So, let us see the consequence of this, and for that we pick up a simple string class having a char star pointer for the containing the string and another variable len to keep the length of the string, and this is the order in which they are given, and there is a print here. So, I first in the C style, I first do a copy of the given string, put the length of that string, and finally, I free up the space created by str_do. In the C++, actually I put them in this same order, and I initialize str first and then len in terms of the initializer list. And what I get to see is, well, it is working fine. I can see the call to the constructor and the call to the destructor, but that is not dependent on the order. Okay. Now, let us question that what happens if I change the order of these data members. If I swap the order of the data member, I first put len and then put the char star str, right. If I just change these two, right. And as you know that the order of construction will be in the order the data members are listed, and you will see that this will cause a disaster, because even though here this is given first, that is you should copy the string s into str, and then you are saying that from the str you will compute the len, though this is the order given, but the order in which they will execute is first the len. So, this will be first to execute and this will be second to execute. Now, obviously, when you are executing this first, you are passing on str the second data member, which is still not been constructed, is still not been initialized. So, it is a garbage pointer basically. So, you are passing a garbage pointer to strlen. So, you do not know what it is going to do, right. So, if you run this program, then there are several possibilities. One is what I found on the main GW compiler that I am using on my Windows machine, is that it does not crash, it constructs, destructs, but it arbitrarily takes some values 20. Well, the actual length of the string path though is 6, right. And when I run it on my Visual Studio, Windows Visuals, Microsoft Visual Studio, then the program simply crashes, saying that there is an unhandled exception, because you have passed a garbage to strlen. So, you will have to be very careful in terms of the order in which if there is dependency between the values of one initialized data member to the other, you have to put them in the right order in the listing of the data members. So, that is what. So, it says that the lifetime of the reason I am discussing it here is, it says that the lifetime of str has to start before the lifetime of len is expected to start, because len depends on the str, right. So, now I have put a number of examples for you to actually trace the constructor destruction and the use of object lifetime. And as you can see here, the title is prefixed with practice. So, we will not get into the details. We will possibly come back using them in different contexts later on, but I insist that you try out these programs, read every line of it and understand it well. So, this is the design of a det class. This is our good old friend point and rect class, and I have shown the expected output everywhere. So, you can check and get convinced that things are happening in the right way. Then there is a name class, an address class. These are all for your practice, including the credit card class, which uses all of these. and if you do that, if you run that, then this is the kind of the magenta is the kind of output that you expect from this, while you have on the right top the design of different classes, right. So, please practice them out to get more confidence. Now, let me move on to the copy issues. The first is a copy constructor. So, what we do is this is a normal construction. We all have seen this. So, when we do this, we can do it by this, or we can actually write it as 4.2, 5.9 like this also. So, it constructs, it expects a constructor which double and it constructs by that. Now, what if you invoke it like this, that C1 is already constructed as a complex object, and you are trying to construct C2 putting C1 in the parameter of this, or putting C1 in the initialization value. This is the point where copy construction is taking place. Why? Because you already have an object of the complex type here or here, and you want to create another object of the complex type as a copy of this object, right. So, the copy constructor takes place. So, in the copy constructor, naturally what you are passing as a parameter is an object of the same type. So, naturally it has to take a parameter which is complex. We will avoid using we would avoid using the call by value, as you know. So, we will put it as call by reference, and we do not want the source object to be changed by this copy constructor. So, we will put a const. So, that is the basic copy constructor design that we will have. So, here is an example of this, where this is the copy constructor. So, what we do is I am passing a object C of complex type to this constructor, and I take the real component of C, copy it to the real component of the object to be constructed. Similarly for, so basically item by item, data member by data member I copy, and if those data members are user defined types, then their respective copy constructor in turn will again get invoked. It is the same process as the construction, where construction in general can take parameters of any type or may not have a parameter for default. In copy constructor specifically, you take an object of the same type. So, when you write this, you are invoking a constructor, and when you are write this or this, you are invoking the copy constructor. And I have put messages here specifically, so that in the output trace you can find out which constructor is being called and in which order. Destructors, of course, will happen in the reverse order, as we have seen. So, this is the basic story of copy construction. So, it is like copying variables we have. Now, we have given ourselves the mechanism to copy any object that we have created for our user defined types. Now, the question is when do you need to do this copy construction? The primary reason you need copy construction is to support call by value. As you know, if you do call by reference or return by reference, then only the reference is being passed, no object copies, as we have seen already. But if you do a call by value, then naturally you need to copy the given actual parameter object to the expected formal parameter object. So, you need a copy, and that copy is what is done by the copy constructor. Similarly, if you are returning something by value, then you will need the copy constructor. So, copy constructor is needed for initializing the data members of an UDT from an existing value. So, this is the reason. Without the copy constructor, you will not be able to call functions by value. So, here I give an example. This is a copy constructor, and I am trying to write a global function which is display, which takes a complex parameter by value. Right. So, I am not putting the ampersand. So, as I take it by value and I call it, so my actual parameter C needs to be copied to the formal parameter C param, right. And when I do that, this copy process will invoke the copy constructor, right, because it has to copy the fields of C into the fields of C param. So, as you can see here easily that initially when you do initially when you are doing this, you have a constructor call, and then when you have not made any explicit copy constructor call here, but when you call display, try to call display, you have a copy constructor call copying C param as a copy of C in display. And then the display is actually called, it does the display process. And when you are done, you are here, you have constructed an object here. So, the lifetime of that object has started, that formal parameter object has started with the call of display. So, when you get to the end of display, your control is going back, you are out of that scope, and by that same rule, the destructor will be called for C param. So, the destructor is called and with the same set of values, and then finally, the destructor of C is called at the end of main. So, this is how the call by value is supported. You can see the same thing if you do return by value as well. So, what should be the signature for the constructor function? So, this is the most common signature, that you pass the parameter to the copy constructor by reference, right, by reference, and you make that a constant, so that the source cannot be changed. It is also possible that you write a copy constructor where you have not used const. You might wonder that while I am copying, why do I need to change the source? See, there is a subtle difference between what we say is a copy and what we say is a move. If I want to realize move, which does not exist in C++ 03, then what I will want is not only make a copy, but actually invalidate the source if required. So, that there is only one, because if you just do copy, there are two copies of the variable. If I just want one, that the source has moved to the destination, then I will need to use this. I will talk about this in more details when I talk about smart pointers and how they use this, and we will come back to that in C++ 11 when we talk about the move semantics, which is specifically supported. So, this is the most common, 99.9% of copy constructors are like this, some are like this, and very rarely you may use other qualifiers like volatile and all that. So, it may also be noted that if you pass a pointer, like if you try to do a call by address for the copy constructor, you will still be able to make a copy, but that is not a copy constructor. That is, if you provide this, the compiler will not use it in the context of call by value or call by reference. So, do not consider that. These are functions, these are obviously some overloaded constructors, but they are not copy constructor. Right? Now, the final question is, why do I need to pass the parameter to the copy constructor as reference? What if I pass it as a value? Now, what will happen if I pass it as a value? Then to be able to call the copy constructor, it needs to copy this value, which in turn needs the copy constructor itself. So, I am passing it call by value. So, call by value needs the value must be copied. That needs the copy constructor must be invoked. And if I do that for the copy constructor, then the copy constructor itself will have to be invoked. So, it will have to be called, and to call that I need to copy the actual parameter again. So, the copy constructor will be called again. So, I end up having an infinite recursion. So, this is not, if you write this, then you will basically have an infinite recursion, you will never be able to end. So, the only way to write copy constructor is by reference, and preferably by constant reference. So, these are again our point and rect class, the different instances. For example, if you see that in the initializer list, you are constructing TL, the top left point by x and y, the integer values. So, this will invoke the normal constructor. But if you are doing this, that is where your PTL is already a point object, and you are trying to create the TL member of the rect class by copying it, then you will have the copy constructor invoked, right. So, you can study it well. The notes are all given explaining what every stage is doing, and understand where does the default constructor come in, what does the copy constructor come in, and what does the other overloaded constructors come in. So, if you run that program and you will see that actually this is the kind of output that you get, and it will be a good exercise that you do not look into this right hand side column first, keep it blank on your copy, guess, take the output, and then try to put the lifetime information as to when things are getting created, when things are getting copied, when things are getting destroyed, when things are getting used, and so on. That will give you a good practice. So, this is yet another practice slide that I have put for you. Now, like the constructor, if you do not provide a copy constructor, then the compiler will give you a copy constructor, right. Now, the copy constructor the compiler provides, because if you have not given a copy constructor and you are using that object of that class by in call by value or call by reference, call by value or return by value, then certainly the compiler needs a copy constructor. So, it will provide you a free one. Now, it does not know what to do. So, what it does, it just copies the bit pattern. Whatever the object had, it copies the bit pattern, right. So, this is called the bitwise copy, fieldwise copy, field for field copy, and so on. So, if you have data members which are just built-in types, whose actually they do not have any specific thing to construct, their values will come properly. But if you have some reference variable, some pointer variable which has allocated a location, then what will happen? This is your original object. Now, if you have copied that pointer value, then in your copied object the pointer value will be the same. So, you have two copied objects having the pointer values which are same. So, they are basically referring to the same object. So, this is a very ambiguous copy, and this might lead to unexpected results, because for example, after cloning, if clone is another process used for referring to the copied object. So, after cloning, if I use that pointer to change this reference object, then the same value will be reflected in the original object also, right. So, this type of copy is called shallow copy, where you are just copying the pointers, because you are doing a bit copy, right. That is what the compiler has given you. The other, which is basically the preferred or the correct way of doing this, is to have a deep copy. So, what you do in a deep copy? In a deep copy, you for the every built-in type you copy the value, for every other data members you call the copy constructor of the corresponding class, and for pointers you actually make a fresh allocation and copy the pointed value as well. It is not enough to just copy the pointer, that is not semantically correct, right. So, you have to explicitly define the copy constructor, assign dynamic memory as required, and put the. So, you will have, in terms of a deep clone or deep copy, your original object is giving you the cloned object, you have a reference object, you are not copying this pointer, rather you are doing a fresh allocation and copying this object by that object's copy constructor. So, that is a big pitfall of having free copy constructor from the compiler, or the pitfalls of shallow copy. So, to illustrate, I have shown here a class with one integer value and one pointed to integer. So, naturally in the constructor a value is a dynamic allocation is made, and that will be deleted later on. Now, I have not provided any copy constructor. So, what the compiler will do? It will provide a free one which will copy everything. So, what happens? I have two objects, one is originally created, the other is a copy of that, which has been created by bit copy, shallow copy. So, when I print the addresses of these two objects, I find they are different objects. But when I go deep and print the pointers, this particular p underscore pointer, that has also got copied. So, they have same values, and both of them will try to point to the same location. Now, what is happening? When I do this, then at this point you can see that my destructor is actually making the print. So, when I come to the end of main, this object will be the first to get destroyed, the last created, first destroyed, right. So, this object, when this object is destroyed, this p pointer is deleted. So, now it becomes a dangling pointer. So, when you go to destroying a 1, which is a first object created, the second to be destroyed, then you are again trying to do a delete p, or you are trying to print the value of pointed to by this, but p has already been deleted, because it was pointed to by a 2 and a 2 has done the destruction, and it has deleted that pointer. It is a dangling pointer. So, you get a garbage value, you might get a crash also, right. So, this is a problem with the shallow copy. So, do not do that, always do deep copy. So, as in the copy constructor, now you can see that you copy the integer variable, because it is not a pointer. For a pointer, you do an allocation and initialize it with the value it was pointing to. Once you do that and you write the same code, now what you have is in the copy, it is not a bitwise copy, it is no more that you have these 2 pointers same. So, in the 2 different objects that you have got, the 2 pointers are of different value, and therefore, when a 2 is destroyed and that pointer is released, the pointer in the a 1 does not get affected, and both of them have the same value, because that is how you have created. So, this is what is deep copy. There are alternate terms also which is used, some use lazy copy, some use copy on write. They are not exactly same, there are semantic differences, and at an appropriate point I will explain that, but the whole idea of deep copy is copy the pointed variable value separately with allocation. Right. So, again practice examples given here with free copy constructor, do carry out through them. There is user defined copy constructor for a string object class, please try that with the free copy constructor, and in the notes I would always suggest that do not read the notes, first understand the program. If you cannot figure out, or after you have figured out what has happened, then try it, build and try to run it. Once you have seen what is happening, then you go to the notes and confirm that your understanding is correct. So, this is how the practice once must be done. Okay. Now, let me talk about the copy assignment. So, other than the construction which we were doing, the other that we do regularly is copy one value into another. So, when I write it, when I write something like complex C2, then I mean a copy construction, because this is an initialization. But if I simply write a statement C1, C2 both are available, and simply write a statement C1 is copied to C2, then I need a copy to be done, which means that I would like to erase the values in C2 and override them with the values in C1. Right? So, this is an assignment. So, this is called copy assignment or assignment. Now, we know operators can be overloaded. So, this operator of assignment is operator assignment. Naturally, it takes the object of this complex type, the source type, which will come as a constant reference. And what does it return? It has to return an object of the same type, because you have copied, right. So, it also returns by reference the same type of object, right. So, here is a copy assignment here, the copy assignment for this, and it returns this. It is not only enough to copy and make changes, like here copying and making changes here, which is fine, but it is also important that it returns the object of the same type. Why do we need that? Because we may want to chain the assignment. For example, here we have chained the assignment. So, C3, so this operator is called first because this is right associative. So, C3 is copied to C2, and whatever is copied, that object is returned, and that then is copied to C1. If you did not return that object that you have copied into, then this second one you will not be able to write. Right? So, to support this continuity of semantics of assignment being chainable, you need to return the same object. So, this is what is the copy assignment. You can see the copy assignment in string. So, if in the string you have a pointer and the length. So, the string is pointing to an allocated memory where you have doped. So, what you will have to do is when you are copying, you cannot simply copy that pointer from your source to the destination object in the copy assignment, because if you do that, then whatever your destination object was pointing to will leak, because that memory gets lost. So, you have to free that up, then do a fresh str dope to do a deep copy, as you have understood by now, copy the length and return the same object. So, that is a simple way of doing this. This works pretty fine, and if you do this with S1 being assigned to S2, you will have a very nice working. Now, what if you are doing a self copy? Instead of this, what if you are now you might ask us, why should I do a self copy, but it is always possible, because you do not in the whole set of programming you do not want to create an operator, because in a built in type of int x, if you assign x to x, then it works perfectly, but here it should also work perfectly, but does it? Suppose you have done this. This is the only change that I have made. Now, what will happen? You have released the memory. Once you have released the memory here you actually wanted to release the memory here in the destination object, but it is same as the source object. So, it has got released in that as well. So, when you are doing this str dope for performing deep copy, it is a garbage value, right. So, it will create either a garbage value or a program crash. So, self copy is a problem in this strategy, and so it has to be detected and somehow taken care of. So, it is very easy to do that, because if you are doing a self copy, then all that you need to detect is the object that you are getting as a source and the current object on which the copy assignment operator has been invoked, that is this pointer. These are the same object. So, what is the identity? The address. So, this is the destination object and ampersand s is the source object. If they are identical, then they are the same object, and therefore, there is nothing to be done for this copy. So, if this is equal to ampersand s, you just return this, that is all. Otherwise, you do this where they are different, and it is going to be always correct, and this is the self copy needs to be taken care of, and otherwise. So, this is what turns out to be what is the basic signature of the copy assignment operator, where you check for self copy, do whatever is required for the deep copy, and then you return this. You can copy assignment operator could also be of this type, like the copy constructor, that is in the first one, which is common, if the source is not changed. In the second one, the source will get changed. So, I might want to move this. There could be several other signatures, but they are rarely used. So, do not try to use them. Copy assignment operator will also be provided free by the compiler, and therefore, it will come with all the issues of shallow copy that we have talked of. Now, before I conclude, just to compare what is the difference, both are copying, constructor and assignment operator. Now, constructor is overloaded, the operator is also overloaded. The basic difference is when you do copy construction, the object does not exist. So, that object has to be created as a copy, whereas when you are doing copy assignment, there you already have two objects and you are changing the destination object according to the source object, right. So, that is a fundamental difference, rest of it is whatever we have discussed in the slides so far. And finally, you have the class as a type. So, this we had seen earlier. Now, with this and this coming in, we have the copy construction, which is also available for the built in type. So, you can see that your assignments, and like in assignments here, you can see that we are actually extending the class and making it more like a perfect type. So, with this I conclude on the module with different semantics of copy, construction, assignment, and deep and shallow copy. Do practice this very, very thoroughly, because this will be critically important in all kinds of things, programs that we write in future. Thank you very much for your attention, and we will meet in the next module.